Okay, ma'am. Okay, madungog ra, ma'am, no? Sige. Okay, good afternoon, everyone. So I am going to report about the spanning sets and linear independence. So we have here the definition of the spanning set. If S is equal to V1, V2 to Vk is a set of vectors in Rn, then the set of all linear combinations of V1, V2, and to Vk is called the span of V1, V2, Vk, and is denoted by the span V1, V2, Vk, or span S. If span is equal to the Rn, R raised to the power of n, then S is called a spanning set of Rn. So we have here an example. So shows that R raised to the power of 3 is equals to the span of the matrix 2, -1, and 1, 3. So in this example, we need to show that then an arbitrary vector AB can be written as linear combination of 2, -1, and 1, 3. That is, we must show that the equation x is 2, 1 plus y, which is 1, 3, is equal to AB can always be solved for x and y in terms of A and B regardless of the values of A and B. So we have here the augmented matrix, which is 2, -1, 1, 3, and AB. And law reduction produces, we have here, if we are going to reduce this one, the row reduction, we have here 2, -1, 1, 3, AB. Row 1, it's like, to row 2, it's like, nag-change ra sila. So we have here -1, 3b, and 2, 1a. So how about we have here row 2 plus 2 r1. So we have here row 2 become 0, 7. It's because 2 times 2 times -1 is 2 plus 2, we have here 0. And we also have here 1 2 times 3, which is 6, plus 1, which is 7. So we have here the result -1, 0, 3, 7, b. And we also have here a plus 2b. At which point is it clear that the system has a unique solution? Why? If we are going to continue, we obtain this one. So we have here 1 over 7 row 2. So this is the result, which is -1, 3, 0, 1, and b, a plus 2b, open parenthesis and close parenthesis, over 7. So then ini siya kini ang gigamit nga murag equation niya 1 over 7 row 2. And we have here from row 1 minus 3 row 2. So we have here -1, 0, and 0, 1. And we have here b minus 3a over 7 and a plus 2b over 7. So we have here the result. Our 2 -1 right here is 3a minus b over 7 plus a plus 2b over 7, which is our 1 over 3, which is equal to a, b. And we have here another example. Let E1, E2, and E3 be the standard unit vectors in R3. Then for any vector x, y, z, we have, which is our x is 1, 0, 0, plus our y is 0, 1, 0, and our z is 0, 0, 1, sorry. So we have here x e sub 1 plus y e sub 2 plus z e sub 3. Thus, R3 equals to the span of E1, E2, E3. So sa aning part Ang gipakita raman dapat ani niya is dapat kini sila na kini si X, Y, Z naa dapat ni sila span sa usag-usa makita niya. Okay, and we have here what is linear independence. So there is the definition: a set of vectors v1, v2, vk which is a linearly dependent if there are scalars c which is c1, c2, ck at the list of one of which is not zero such that c1 v1 plus c2 v2 plus or anything else ck vk is equal to 0. A set of vectors that is not linearly dependent is called linearly independent. So in vectors v1, v2, and vectors, it's supposed to be that these vectors are linearly independent if and only if at least one of the vectors can be expressed as a linear combination of others. So we have here an example. We have here the matrix 1, 1, 0, 0, 1, 1, and 1, 0, 1. In answering this question, it is a good idea to see if you can determine by inspection whether one vector is linear combination. So we have here, in answering this equation, we need to find scalars first. We have here our scalar C1, which is 110, C plus C2 011 plus C3 101 is equal to 000. So we have here our corresponding linear system, which is C1 plus C3, which is equal to 0, and C1 plus C2, which is equal to 0, and C2 plus C3, which is equal to 0. So we have here our augmented matrix. We have here 101, 110, and 011, which is equal to 0. So if we're going to reduce this one right here, so this is the result. So our scalars right here is all 0. So C1 is 0, C2 is 0, C3 is 0. Thus, the given vectors are linearly independent. And we also have here the standard unit vectors E1, E2, and E3 are linearly independent in R3 since the system the system with augmenting matrix E1, E2, E3 is equal to 0 is already in the reduced row echelon form. So we have here in the screen. And so clearly has only the trivial solution. In general, we see that E1, E2 will be linearly independent in Rn. Okay, and we have another example. 1, 2, 0, 1, 1, negative 1, and 1, 4, 2. So if you're going to construct a matrix with these vectors as its rows, I proceed to reduce it to the echelon form. So each time a row changes, we denote the new row by adding a prime symbol. So we have here the solution. 1, 2, 0, 1, 1, negative 1, 1, 4, 2. Now, if we are going to reduce this one, R2 minus R1, 1 minus 1 is equal to 0, right? Then 1 minus 2 is negative 1, and negative 1 minus 0 is negative 1. So we have here the result 1, 2, 0, 0, negative 1, and negative 1. And we have here the R3 minus R1. 1 minus 1 is 0. 4 minus 2 is 2. And 2 minus 0 is 2 in the row 3. And we have here R3 plus 2R2. This is the result if you are going to do this one. 1 0 0 2 negative 1 0 0 negative 1 0. So ang nausog na niya is ang row 3 which is all zeros na. So from this, we see that 0 is equal to R3 plus 2R2 equals R3 minus R1 plus 2 R2 minus R1 is equal to negative 3R1 plus 2R2 plus R3. Or in terms of the original vectors, we have here our negative 3, which is the 1, 2, 0. Our 2, which is 1, 1, negative 1. And we have here 1 for 2, which is equal to 0. So linearly dependent sila, independent. And we have here the applications. So first is the allocation of resources. So we have here an example. A biologist has placed three strains of bacteria denoted 1, 2, and 3 in a test tube where they will feed on three different food sources A, B, and C. Each day, 2,300 units of A, 800 units of B, and 1,500 units of C are placed in the test tube, and each bacterium consumes a certain number of units of each food per day, as shown in the table below. This one. So we have here the bacteria strain number 1, bacteria strain 2, bacteria strain 3. So we have here the given food A, which is the bacteria strain 1 is 2, the bacteria strain 2 is 2, and the bacteria strain 3 is 4. And we have here the food B, the bacteria strain is 1, the bacteria strain 2 is 2, and the bacteria strain 3 is 0. And we have here the food C, which is the bacteria strain 1 is 1, the bacteria strain 2 is 3, and the bacteria strain 3 is 4. 1 rather. So we have here an equation. So 2x sub 1 plus 2x sub 2 plus 4x sub 3 is equal to 2,300. So likewise, we obtain equations corresponding to the consumption of B and C, which is our x sub 1 plus 2 sub 2 is equal to 800, and x sub 1 plus 3, x sub 2 plus x sub 3 is equal to 1,500. Thus, we have here a system of three linear equations in three variables. So we are going to row reduction of the corresponding augmented matrix gives. So we have here the given 2, 2, 4, which is the 2,300, 1, 2, 0, which is 800, 1, 3, 1, 1,500. So if we are going to reduce this one, we can have this result 1, 0, 0, 0, 1, 0, and 0, 1, 001, and we have here 300, 150, and 350. So this is the solution that I have early. So this is dada dari ang last, which is 100, 300, 010, 150, and 001, 350. So I use the row reduction of the matrix. Kapra sa discuss kaniha ni ma'am. So therefore, our x sub 1 is equal to 300, and our x sub 2 is equal to 150, and our x sub 3 is equal to 350. Okay, the next one is balancing chemical equations. So, pas ra ba? Okay ra? So we have here the balancing chemical equation. So ikaduha ni siya sa application. So we have here an example. So let us define first balancing chemical equations. When a chemical reaction occurs, certain Molecules combine to form new molecules, which is the products. A balanced chemical equation is an algebraic equation that gives the relative numbers of reactants and products in the reaction and has the same number of atoms of each type on the left and right hand sides. The equation is usually written with the reactants on the left, the products on the right, and an arrow in between to show the direction of the reaction. For example, we have here the hydrogen gas, oxygen combine to form a water. So we have here a balanced chemical equation, which is this part right here. So we have here another examples. So the combustion of ammonia in oxygen produces nitrogen, and water. Find a balanced chemical equation for this reaction. So we have here the solution. If we denote the numbers of molecules of ammonia, oxygen, nitrogen, and water by our W, X, Y, and Z respectively, then we are seeking an equation of the form W, which is here our nitrogen and hydrogen, plus our X is the oxygen and our Y is the nitrogen plus the water. So we are going to compare the numbers of nitrogen, hydrogen, and oxygen atoms in the reactants and products. So we obtain three linear equations right here. So we have here the nitrogen, the hydrogen, the oxygen. So in this case, we have here the nitrogen, which is 2y, the hydrogen, which is 3w, is equal to 2z, and oxygen 2x is equal to z. So if we are going to write this one, we have here the matrix, which is we have here 130. It's because earlier our equation was this one. We have nitrogen, hydrogen, and nitrogen is 1, hydrogen is 3, and our oxygen right here is on this part W is 0. So we have here 130. So the next part is nitrogen. There's no nitrogen, so we are going to write a 0. Hydro- Hydrogen, which is 0 in terms of X. And we have here the oxygen, which is 2. So we are going to write here 2. The next one is we have here our Y. The nitrogen is 2, right? And there's no oxygen and nitrogen, oh, hydrogen. And we have here our z, which is 0, -2, -1. So morning negative ni siya kay naa man gud siya ani nga nabilong. So we will be using negative. So we have here 0, 0, 0. So if we are going to write this one or to put this one in a calculator, so mao ni ang ma-result, which is 100 negative 2 over 3, 010 negative 1 half, 001 negative 1 third. So in this case right here, if you're going to input these equations right here in the calculator sa matrix, so mao ni ang mogawas nga equation. So thus, we have here W equals 2 over 3z, x is equal to 1 half z, and y is equal to 1 third. So the smallest positive value of z that will produce integer values for all four variables is the least common denominator of the fractions 2 third, 1 half, and 1 third. So which is 6, right? So if we are going to reduce this one, 2 third. So 6 times 2 is equal to 12 divided by 3 is equal to 4. We have here the 1 half, 6 times 1 is equal to 6, divided by 2 is equal to 3. So we have here our x, which is 3. And for one third, 6 times 1 is equal, 6 times 1 is equal to 6 divided by 3. So we have here our y is 2 and our z is 6. So therefore, the balanced chemical equation is 4 and H3 plus 3 O2 is equal to 2 and 2 plus 6 H2O. So kining apart ani pwede man ni siya mamano-mano pero mas taas-taas pa di siya. So mo tong nagtry ko gamit sa calcu. Alright, so we have here the last application, which is the network analysis. So ani sa network analysis, medyo naglibog pa gamay. So we have here, there are many practical situations gave rise to networks such as transportations, communications, and economics, and etc. So we have here for us, a network will consist of finite number of nodes, also called the junctions or vertices, connected by a series of directed edges known as branches or arcs. So each branch will be labeled with a flow that represents the amount of some commodity that can flow along or through that branch in the indicated direction. So think of cars traveling along a network of one-way streets. So the fundamental rule governing flow through a network is conservation flow. So we have here at each node, the flow in equals the flow out. So we have here an example. So the conservation of flow rule implies that the total incoming flow, if F1 plus F2 units, must match the total outgoing flow 20 plus 30 units. Thus, we have the linear equation F1 plus F2 is equal to 50 corresponding to this node. So our F1 here is 20, our F2 right here is 30. So F1, which is 20, plus F2, which is 30, is equal to 50. We can analyze the flow through an entire network by constructing such equations and solving the resulting system of linear equations. So we have here, at each node, we write out the equation that represents the conservation of flow. We have here the problem first. Describe the possible flows through the network of water pipes shown in figure 2.11, where flow is measured in liters per minute. So we have here the figure 11. So mao ni ang iyahang given. We have here 10. This is our F1, F2, F3, and F4. So we have here, at each node, we write out the equation that represents the conservation of flow there. We then rewrite each equation with the variables on the left and a constant on the right to get a linear system in standard form. So we have here node A15, which is F1 plus F4. And we have here node B, which is F1 is equal to F2 plus 10. Node C, F2 plus F3 plus 5 is equal to 30. And node D, F4 plus 20 is equal to F3. So we have here this equation, F1 plus F4 is equal to 15, F1 minus F2 is equal to 10, F2 plus F3 is equal to 25, and F3 minus F4 is equal to 20. So sa aning nga part, medyo galibog pa ko nagiun sa lipag kuan ani. So mao ni ang iyahang table nga gi-referan. So we can use also the Gauss-Jordan elimination. By doing this, we reduce the augmenting matrix, which is 1, 1, 0, 0, 0, negative 1, 1, 0, 0, 0, 1, 1, and 1, 0, 0, negative 1, 15, 10, 25, and 20. So if we are going to reduce this one right here, this is the result: 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 1, 1, negative 1 zeros, 10, 5, 25, 0. So sa aning nga part, i-reduce din siya into row echelon form or the ref, and mauni ang iyang nakuha nga result. So I forgot kung na hatag ba na ho ang pag-solve ani. So, gi-reduce din sila in terms of row kapra sa gihatag ni ma'am ganina examples. So, each row kailangan turn dapat mahimo ang ingani nga style, which is this one. So if we're going to check this, we see that there is one free variable, which is f4. So we have infinitely many solutions setting f4 is equal to t, since t is just 0, and expressing the leading variables in terms of f4, we obtain f1 is equal to t 10 minus t, our f2 is 5 minus t, and our f3 is 20 minus t. And since our f4 right here is 0, so f4 is equal to t. All right, so for this one, do you have clarifications or questions? I-stop sharing na ni ma'am, or thank you.